Okay, so now what I want us to do is to compare the traditional neural network with the recurrent neural network. Okay, so whether the traditional vanilla neural network or the CNN. Okay, I want us to compare that with the recurrent neural network that we are talking about right now. All right. So in the traditional neural network, we have our data points. Okay, we have our data points. Then we multiply it with some sort of a weight. And then we have some hidden state over here. Okay, we have some hidden state over here. And then we get our output. Okay, we get our output. We also multiply it by some weight over here. Okay, before we get our output. Okay, depending on the number of units that we're going to predict. Okay, depending on that. So that's basically what happens. I mean, in a straightforward manner, it's like this. Okay, you have the input, you multiply it with some weight, you apply some sort of a non-linearity. Right, and then you have some hidden state, and then you multiply it with some other weight, and then finally you have your another non-linearity over there, and then you have your output. Okay, so it's going to be something like that. That's for the neural network, right? The vanilla neural network. Okay. Now, when it comes to the recurrent neural network, okay, when it comes to RNN, right, recurrent neural network, you have your input, all right. Okay, you multiply it with some weight, just like this. Okay, and then you also have the non-linearity over here. Okay, you have some non-linearity over here. Okay, now instead of just this input like we have over here, where we have this one multiplied by the weight, and then you apply the non-linearity over here, which is in this case is ReLU, right? Instead of just that, we also have the input, right? The hidden state from the previous one. Okay, the hidden state from the previous one, which is also going to be multiplied by weight. And then both of them, we applied this non-linearity on it, right? And then we have another hidden state for the current layer. Okay, for the current layer. And then now we can multiply this one with another weight, right? And then apply another non-linearity on it and get to the final output. Okay, so that's basically what happens. You have your input, you multiply it with some sort of a weight, okay, and then you're going to apply some non-linearity over here, right? And not just that, you also need to take into consideration the hidden state of the previous layer, and then multiply it with some weight, and then both of them come together. You apply the non-linearity on that, right? And then you get the current hidden state, and that current hidden state can be multiplied with another weight over here, okay, and then apply another non-linearity on it, and then get your final output. Okay, that's what happens when it comes to recurrent neural network. So the difference here is that we are incorporating the previous hidden layer with the weight, okay, and then we get to the current hidden layer, and then now we can apply the weight to the hidden layer and apply some non-linearity on it, and then get our final output. Okay, now this is just one of them. Okay, this is just one of them. As I said, it's kind of a loop, so this thing is going to be repeating over and over again. Remember, it's recurrent. It's going to continuously recur. Okay, so it's something like this. Okay, it's going to be something like, so this is just representing one of these, so it's going to have multiples of them like that, going to like operate like that. Okay, so just one of them, right? One of them is going to take the input from the previous hidden state. Okay, so that's what you're seeing over there, multiply by some weight, and then this one will come, and then you get a hidden layer for this one, okay, HN, right? And then you multiply with some weight and get the output. This is going to be applicable to all of them like that. Okay, so you're going to have a chain of them. Okay, so this is just one of them, and then I'm explaining the architecture for you to understand. Okay, so you're going to have a chain of them like that. All right.